Hello, thank you for having me. My name is Damien Fair. I'm a professor at the University of Minnesota and Red Leaf Endowed Director of the Masonic Institute for the Developing Brain. I'm here to talk about working with large data sets, open data sets for this education course. I'm glad to be here. So there'll be a few main goals here. One is I'll talk about the importance of working with large open source open resources. Some basic resources and educational courses that are available. And then a few of the open data sets that I'm a part of, the Adolescent Brain and Cognitive Development Study, ABCD study, and the Healthy Brain, the area there, and Child Development Study, HBCD. And then I'll end with some thoughts and conclusions. So I'm going to start here with this paper. This is a phenomenal work by Scott Merrick and Brendan Turbo Clements on reproducible brain-wide association studies. So we received a lot of news and press recently by our field, and I think it's a good example of the importance of open source data sets and that we be able to leverage them for our own work. Now, there was basically two main questions that this study was trying to answer. It asked, specifically, what are the expected effect sizes of brain behavior correlations? And then the second is, does the reliance on typical neuroimaging sample sizes provide an explanation for why replication failures might exist in brain-wide association studies? And if so, why? Well, the gist of the findings were this, is that effect sizes are generally quite small. And no matter how you do it with structure and function and psychopathology and cognitive ability, that effect sizes are generally small. And that typically means you need much larger data sets. There's several reasons why this is. And one is because of sampling variability, which is simply that it's simply sampling variability is a random source of error, and that increasing sample size is the only real way to decrease sampling variability. And this, along with systemic sources of error like methods variability, p-hacking, publication biases, and things of that nature, require much larger data sets for us than we had ever typically imagined. And the observed effect sizes suggest that these consortial level data are required to detect brain phenotype associations upwards of 1,000 to 2,000 subjects, which is quite large from what we expected. So the conclusions here, again, in very brief terms, is that in the era of big data for neuroimaging, many types of questions, for example, not all, but many, for example, these brain-wide association studies are likely going to require a large community of collaborators that are both contributors to open source data sets and that are leveraging them for their own work. And so that takes me to, well, what are some of the resources out there in educational courses that you can use? I'm only going to name a few, the ones that I'm most familiar with. There are others, and there are many, but I'm just highlighting them because either I'm contributing them myself, or I know a lot of the work that's being done, and they're very good resources to really encompass much more than I can possibly talk about today in today's education talk. One of them is ReproNIM, the Center for Reproducible Neuroimaging Research and Computation. They have a great website, awesome courses, a ton of material, and it really is a go-to for how to think about and leverage your own work for using large open source data resources. Many folks are familiar with some of the early open source resources in the Human Connectome project. There continue to be courses that are done online, but even from the old courses, there's a ton of material about how to leverage various types of tools, both computation, viewing, visualization, processing, analytics, and just some general education that is really strong in these courses. Now, a lot of that is specific to the Human Connectome project, but a lot of it is not. So I think that It's another great resource. Of course, there are several meetings, including this one right here, that routinely have hackathons, educational courses, and a lot of resources that are, in fact, I believe there's some going on right now, a lot of resources that are really geared toward trying to understand and leverage a lot of the new and growing lists of resources available with regard to data. And last, I'm just going to do a little plug about Flux. The two big data sets I'll be talking about today, the ABCD and HBCD studies, are routinely highlighted at Flux. Lots of talks and discussions, including this year, describing how to use these resources, the importance of the resources, what new tools are coming out every year. We'll be in Paris this year. It's going to be a great time. You should feel free to come. And if you're really into this topic, you're going to learn a lot. Okay, so now I'm going to go on quickly to where the bulk of the talk will be today is on the ABCD study and some resources, new resources and tools that are available to really help folks utilize this data set, but also leverage the data for their own work, or utilize some of the tools in combination with other open source resources as well. All right, so just a brief background. Most folks are familiar with the ABCD study now. It's a study of nearly 12,000 9 and 10-year-olds that were initially scanned about 7 years ago now, or started scanning about 7 years ago now. And the plan is to scan them every other year for a total of 5 visits through when the kids are 19 to 20. We're now coming up close to, in the fall, the 5.0 release. Everything up to 4.0 is now released. And the study, I believe now, as more of these longitudinal data have been coming in, have really provided fodder for lots of ways to think about the brain, its association with complex behaviors, and many other topics. Now, at the end of this 12-year effort, there'll be nearly 25 million non-biological measurements will have been collected in each participant. We'll have 5 MRI scanning sessions consisting of 12 distinct MRI acquisitions, totaling about 700,000 scans. It's large, it's big, right? The ABCD must acquire lots of protected health information. That's often secured via the National Data Archives of the NDA. The ABCD team releases demographic, behavioral, and raw neuroimaging data in near real time in the form of these fast track releases that can be downloaded directly from the NDA. In addition, the DRC provides a yearly updated condensed tabulated data release that currently is released through the NDA, but there's likely to be some changes to that shortly in version 5.0. There are some minimally pre-processed data sets where distortion correction, bias field correction, and motion correction have been applied. There's a nice paper describing all those details, and the data collection you can see here is in the NDA is 2573. And there are also a growing list of resources through the Data Exploration and Analysis Portal, or DEEP. It is a tool online. It is a tool online that can be leveraged via NDA credentials to both analyze your data, search data, download data, and that is expanding rapidly for the release 5.0, and actually will be used for distributing some of these tabulated data for the next official release. Many folks now know many about those tools, but there's some other things that I want to show you today. So because for derived measures from the community, there's really the only real mechanism to share subject-specific data through ABCD is through the NDA, and that can be a little bit difficult. So, led by Eric Fezco, who's now assistant professor at the University of Minnesota, there's a nice bioRK paper on all of this. That's the paper I believe is now out or close to be. it's for review. But the who's built this the ABCD community collection, a BIDS community collection, or the ABCC. It's the NDA collection 3165, which has a humongous effort by lots of folks in my lab, in Eric's lab, but also from the community and ABCD to provide an avenue of derivative data for the community, correlation matrices, services, thickness task maps, volume measurements, personalized networks, and other community type measurements, several tools for kind of home processing and analytics, and including running some commonly used software on the data, including fMRI prep, QSI prep, ABCD BIDS processing, which I'll talk about shortly, and some replication and validation tools like match samples, which we call ARMS, which I'll briefly run over. There's lots of new tools that are out there to make some of these large open source data sets actually accessible. So the ABCD BIDS community collection enables community contributions and usage. It has standardized formatting and a governance structure for contributions to maintain some compliance with the NDA's important data use standards. In essence, making the process a lot easier for our community. There are some specific links I'm just highlighting down here for both comments and wants, essentially, but also just read the docs page with all the information on the various releases and upcoming things and all that nature. Now, the standard, or the ABCC, is built on the BID standard, which folks are now familiar with. Again, as we start to standardize more of our measures, which is really important for community sharing in some of these large data sets. There's other easy tools to make it easy to download the data directly to your own environment. There's tools to easily convert raw data from the NDA into BIDS format, or ABCD DICOM to BIDS. There's file mapper tools to kind of reduce the size of some of these data sets on your own system, but do it relatively easily. And we've tried to we've done the best we can in building some tools for making it easier to work with the team to upload your data directly to the NDA into the ABCC. Now, one of the tools, which is the ABCD reproducible match samples, which we think is important for kind of replicating some of your data. There's essentially 3 group samples that are matched on many different demographics, age, sibling status, male, gender, and lots of other demographics that are purely matched, split into 2 specific groups, and actually a third group for templates and other types of testing, validation testing that can be used. And I'll show you one example of that that can be used for different types of analyses. In fact, these specific reproducible match samples are even used in that fine paper by Merrick and by Scott and Brendan. Several other utilities. One of these utilities, again, is the ABCD BIDS pipelines that I'll just briefly go over some of the features. That's freely downloadable. It's all Dockerized and easy to use. It is based off the human connectome pipeline procedures, but made to be a little bit more generalizable for your own data, and to be applied, efficiently across all the vendors that exist in ABCD. I'm not going to go through all the details, but it includes both volume processing and surface processing and surface registration, and incorporates several commonly used parcellation schemes. It's got a very minimalistic interface that makes it quite easy to use. There are many additional options that are available, but it can be run by providing simply BIDS inputs and outputs folders. And so it's very simple and, again, easy to use for the user. There's several different options and specific differences with the human connectome pipelines that I won't go through all the details, but something to think about, including specific quality control management modules, respiratory and artifact filtering parameters, a new functional connectivity preprocessing module, and things of this nature. Importantly, it works obviously with ABCD data. It will work with legacy non-ABCD data acquisitions. In fact, in the era of standardization, it's been used for lots of other data sets, including ABIDE, OHBM, and others. Works with specialized populations that have unique anatomy, like those in aging with large ventricles. And again, with the idea of trying to build some standards to help collate a lot of these other open source resources. Again, there's easy to use HTMLs and executive summaries to quality control your data, surface quality, bold gray plots, essentially look at motion and other types of artifacts, ways to look at clear registration, and all easy to use interfaces. There's a few new things that I think people will be excited about that are coming. We're now highlighting the compatibility and comparability of this pipeline with fMRI Prep and XCP, which comes out of Penn and Ted Satterthwaite's group. It's being made compatible with CPAC out of Mike Milham's group. So lots of those features are upcoming, really building community now on software and standards. Compatible with QSI Prep, which has been just recently released, and a lot of the data releases on this front into the ABCC will be happening very soon. Already there's data releases on fMRI Prep in the ABCC, and there's specific task modules that are also now available and released, and data for that is already released in the ABCC as well. There are, like I said earlier, there's a paper on this. There's a nice read the docs page for all the information that you can possibly imagine on this particular resource. And if you want to provide input, ask questions, give summaries, there's a GitHub page that allows all of that communications and follows it and checks it in for easy search and follow up. Now, I think I want to just highlight a couple of things that's related to the original paper that we talked about earlier, and that is kind of how the other fields in our space have changed over time to kind of embrace open data resources, open science, and combine resources to make our utilization of these open data sources accessible to the masses. One of those, of course, was in genetics. Just like we're learning now about the size and scope of some of the data we need to do reproducible science, it's not new. In fact, I pull up this paper only because it reminds me a little bit of what we feel our place is in the science today. Where, with effect sizes being small, you can easily calculate the sample sizes that are required to be able to have enough power to ask specific types of questions. You can relate that to what the actual literature shows in terms of sample sizes, and the sample sizes tend to be much lower than is actually necessarily required. And there's this nice new quote, that was in this paper. And again, it's one of the reasons why I picked it, just to show this example, and that, in this new era of big data and small effects, a recalibration of views about groundbreaking findings is really necessary. And it kind of highlights why the field in genetics changed so drastically over the course of the last decade and a little bit more, and why it's very likely in the future for our field, we're going to be changing at a similar rate. There's lots of things we can learn, from those efforts. And one of them is how you can leverage some of these very large data resources like ABCD and the UK Biobank to combine lots of these small effects to look at smaller samples and targeted data that may exist even in your own laboratory. Many of you guys have heard of polygenic risk scores. That's essentially what they do with a very specific ways to kind of get workflows to both validate and test smaller data sets by combining a bunch of small effects that may exist in the original data set, and led by Anders Dale's group and Chun Fan at UCSD. There has begun to be more of a push of some of these unique types of multivariate techniques to be able to utilize in these data, in our data, utilize and leverage these large data sets to look at somewhat smaller ones. So, like in my group, we've been kind of testing some of these ideas by using those split data sets like ARMS, and both testing and validating some of the findings that we're seeing in the literature, and then using those combined effects, in this case, in the course of these polyvertex risk scores or polyneural risk scores, to look at smaller samples. In this case, our Oregon 1000, which has about 400 subjects with imaging. And what we're finding is that the ability to generate these scores and things like executive function, memory, general ability, emotion regulation, based on the ABCD, and testing and out of sample in relations to things like symptom scores and ADHD, is that we can explain lots of the variants and do it highly, highly reliably. And so coming soon, right, are basically a lot of these tools to help the community in the ABCC and other places, to help the community kind of leverage some of these large data sets to look at smaller ones. If you look at some really nice papers from Thomas Yo, be at the meeting, you should stop him and ask him. He's got some really similar ideas that have recently been published that are really highlighting how you can leverage these large data sets for looking at smaller samples. Now, there are a few things that we have to be careful about, and there's some lessons learned. This is one of them, is that we have to make sure that a lot of these large samples and how we're using these large samples are maximally representative. As the data become more reliable and more precise, the demographics and the folks who are included in the studies really matter. And I think we can learn a lot from the field of genetics, who are dealing with this right now, where many of those early large studies were primarily folks of European descent, and not surprisingly, how well they predict outcomes were very good with folks with that same background, but folks with other types of backgrounds, not so good. And what that means is that we have to do a really good job at making sure that the data that we're using and leveraging with a lot of these new tools are maximally representative. Now, how do you do that? Well, there's other things you need to consider, even in studies like ABCD, which are population based, where we've done as best we can, although it could be better, of being maximally representative of the community writ large. But then even in that context, there's lots of variability in terms of data quality that need to be considered. So this is just an example of characteristics in ABCD of the effects of different things on motion characteristics, which usually leads to throwing out data like in bold data and functional connectivity and things like that. There's a huge effect of sight, but also a large effect of race and gender, obviously age. And so if you're kind of trimming or your data based on some of these characteristics, you may not be as representative as you believe you are, even though the data collection has been doing its best to be maximally representative. So these are all considerations as some of these new tools come out and we start using them, that we have to make sure that we're considering. Now, I'm just gonna end this piece here with just a couple of highlights, that there are a couple of important emails and places for folks to, at least in this case, to be able to utilize to get help. There's the ABCD's issues email. There is a mailing list that you can apply to get updates on things. So always, that's something to consider for these data. Obviously, there are lots of NDA webinars and various types of tutorials related to this. Also, NDA help desk, and they're usually pretty responsive. So if you need help, you should make sure to, with any of the existing data releases, be sure to look at these places. All right, So now I'm just going to briefly touch on something that hasn't even started yet. It's about to start. But I wanted just to get people aware that here's some other resources that are coming your way. And that's related to the Healthy Brain and Child Development Study. So the Healthy Brain and Child Development Study is a longitudinal observational study that aims to understand normative development from birth to 9 to 10 years old. The recruitment end is approximately 9,500 with the goal of hitting, somewhere between 7 to 7,500 participants over the course of the study. The emphasis is on providing information on the impact of in utero experiences to potentially harmful substances and environments, but also a normative study across from birth through approximately 10 years of age, where the ABCD study had started. Now, this study is also doing its best to be maximally representative. It's 25 sites across the U.S. Here's just a plucking of the different counties, that are being represented or will be represented in the study, and a smattering of folks across different areas of the U.S. Now, I'm just going to highlight some of the new ways and potentially lessons learned from the ABCD study that we're trying to kind of update, a few things from the HBCD study. This is just a workflow of the entire data flow of how the data core is being organized, where data acquisition are flowing into a LORS, a tool out of McGill that's been widely used across the world for many large-scale studies for multimodal curation. This tool has lots of access controls that can allow for specific public access of the data, searchable data access, but also a key into a high performance computing through an organizer called CBrain. Here, this tool is going to help organize several compute environments to provide some access to, over time, the study to provide access to compute so people aren't having to always download this humongous data sets and try to leverage their own local computing, because sometimes without proper access to high performance computing, utilizing some of these really large data sets can be very difficult. And so we're trying to develop an environment to make it completely flexible, where folks who may not have the right resources still have access to the data, and we can even have a larger community providing input on how the best utilization of some of these really large resources. We're doing our best to make sure all the data are standardized, again, to make them combined with other data sets, like from the HEAL initiative. There'll be a lot of public data access through similar tools that we're leveraging from ABCD, like DEEP. So that all the tools being built for ABCD will also be available for HBCD. We're building some sandbox environments so folks can begin to play with the data, even using notebooks and RStudio and all your common neuroimaging software. So even if you don't have a canned pipeline, or you just want to test something out, that you'll be able to do that without having necessarily to download the data. There is a secure environment for any type of analyses that require sensitive data that will require necessarily to be on the IRB, but all of these tools are being put together to, again, make things as accessible as possible to the community. All right, so I'm just going to end with a couple of thoughts and conclusions. The era of big data in neuroimaging and cognitive neuroscience are highlighting the need for open science and open data resources. I think that is very clear. The new tools to effectively utilize these resources are coming online every day, but it really is an all hands on deck approach. We need everybody to contribute. Everybody needs to contribute, and that's what's really going to accelerate our discovery. Now, it's a very exciting time in our field. In fact, now that we understand the parameters on how to conduct these reliable, replicable studies, of this sort, discovery and application, are going to accelerate significantly over the next decade. And I'm very much looking forward to seeing what discoveries you all here make. So I'm going to end there. I'm just going to say thank you for, of course, my lab and all the folks who are involved in many of the things I showed you today. But it's been a pleasure. I hope you enjoy the lecture. Bye now.